have a look and prepare those kind of the aspects. That is one thing. And of course, I'm as a part of these particular sessions and these things. Anything if I feel definitely helps to you, I'll be sharing those things. Though we have seen in the sessions, maybe they are in a different context. So maybe some other curriculums for some other clients. Okay, we are recording actually, so that I thought of sharing the same. Okay.
No, that's good. You know, from starting to end, at least
yeah,
it's
exactly.
kind of
Exactly.
from beginners to at least to a level where they can start practicing.
Exactly, you're right. Because nowadays, you know, that NumPy and Pandas, a little bit we have seen. And in addition to that, we have covered in case of the algorithm implementations. But apart from that, if you want to perform additional aspects like, you know, the arrays out and out, usage of the statistical functions and all those kind of things is a primer kind of thing, so that you can simply practice. And one more thing, as usual, if you observe the pandas way of doing the things, loading of the data and performing some kind of the operations on the series, and then just we have seen some data frames. Okay, all those kind of the conventions, and that is what.
Even my doubt of do you remember, like for when we are doing linear regression, that axis x is equal to 0, I did not understand at the time. Then we just I just bluntly like thought that
Followed.
okay, there is only one column, we have to put that axis is equal to like whatever 0.
Exactly, you're
Then
right.
yesterday's video that got me the clarity,
Yeah,
whether row
because you
wise
know,
or column wise.
yeah, that's what. Suppose if I want to add a row, or if I want to add a column, or if I want to drop a row, or if I want to drop a column, axis defines actually. So that axis equal to 0 or axis equal to 1, and you would have seen some kind of the mean computing also. So definitely helps you to leverage the aspects. Okay, now
I think we can start
yeah,
because
yeah,
Suresh is also having problem with throttles.
yeah.
To photo guess.
Yeah, we are not going to wait because already 6 or 7 sessions we missed. And yeah, definitely the see, just if you refer the same again, we were in the edge of this particular completion of the algorithms. And as a part of that particular thing, friends, we have seen two important considerations. First thing is the supervised learning, and second one is the unsupervised learning. So to set the context, can someone help me, friends? Which are all the aspects we have seen in the supervised learning? Which are all the algorithms?
We have seen two types in supervised learning. One is regression and classification.
First one
Then
is the regression. Second is the classification. Okay.
Regression, we deal with the values, where we have seen simple linear regression, multiple
regression. Okay, these two things we have seen. And in case of the classification, we deal with the yes or no kind of thing.
Yeah,
okay, there we have seen KNN,
SVM, naive bias,
SVM, naive bias,
logistic regression, decision trees,
logistic regression, and now we are going to already we have seen the decision trees. So these things, and now we are going to discuss the random forest. Okay, so let me introduce what exactly the random forest, and then we'll jump into the discussion of the unsupervised learning, so that to give you a different journey. Okay, because again, if I'm talking about the random forest, concept wise, there is a distinction, guys. Like, you know, in a simplest way, I can say collection of decision trees. Okay, collection of decision trees is nothing but the random forest. Okay, that means I'm having some set of the decision trees, and all those particular decision trees together. If I am integrating, this is nothing but ensemble. Okay, ensembling means is a kind of adding multiple source decision trees, and we are going to form a kind of random forest. Okay, so random forest helps us to generate, okay, so a new find of the new kind of the classification algorithm with multiple decision trees. Now tell me one thing, friends. So far, if you observe the decision tree capacity, what is the benefit in the latest session we had in the last year or last month or whenever? So what is this decision tree benefit? Basically, that time we have seen actually.
It gives the result, and it easily computes the calculation.
Interpretability is easy. Then
works good for both categorical and
very good. It is good for both categorical or numeric or some kind of the continuous data.
to feature importance.
That one. Okay. So the feature importance plot, all these things, and of course you can fit the classification model or else the regression model, but we have seen the caution also there. Though these classification algorithms can be used for the regression, but we will be getting the best accuracy with the same type, friends, because we cannot induct a CSE person to go and have the civil or mechanical kind of the understanding, because CSE is basically the coding kind of thing and some kind of the computer science oriented. So we can induct the context, but whereas if you are giving some kind of the context of other branches, definitely is not compatible, though he can learn or he can do something similarly. Though classification algorithms starting from the KNN and our SVM, okay, you know, decision tree, random forest, all these things can be used for the regression also logically, but still we can get the best, okay, out of these kind of algorithms with the notation of the classification only. That point we have to observe. Okay, now so if you are referencing the random forest, so if I'm talking about this particular random forest, it is also a tree kind of the algorithm, but only the advantage is compared with the decision tree for the entire data set. So just we'll be having a single decision tree, and within that we are going to perform some kind of the inference or matrix. Can someone help me, friends? So how a split of the root is done in the decision tree? Very important.
We have three things. One is by entropy or
Entropy,
information gain, Gini index.
Gini index. Okay. This is the information gain. Which one should be high?
Entropy should be low, information gain should be
high. Okay, this is a reciprocal equation actually. Entropy and as well as information gain. Gini always high. This should be based on that particular Gini value. So we have seen both the implementations. Okay, both Gini and as well as the entropy we have seen. Similarly, here also, friends, random forest is not a big deal actually. Only the thing is a latest or a revised version of the decision tree. Here the thing is one more important thing is bootstrapping. What do you mean by this bootstrap, friends? Have you heard about this bootstrap? So bootstrapping is a process of, okay, so just if I'm having some data with me, okay, so based on this particular data, I need to pick up all the possibilities. Randomness is there, na? The word random forest. Okay, that means whatever the data I'm having, randomly it should cover all the samples in the format of the trees. In the format of the trees. And one more important thing is it is going to explore all the possibilities so as to analyze the data in a better way. Okay, so it is going to analyze the data in a better way. So this is the most important considerations we have to observe. Now, as usual, if you are referencing the measures, can someone help me? Which are all the metrics we can use for the random forest?
Confusion matrix.
As usual. Okay, no, they may not ask you guys which are all the metrics in classification. They may ask some algorithm name also. In that case, confusion matrix. And then
Accuracy score.
Accuracy score. Very good.
And might be classification report.
Correct. Sometimes we have used this thing also. Classification report. Okay, so based on these kind of the considerations, you can observe the implementations, nothing more. Okay, only the thing is it is a way of covering all those possible outcomes, and it is helping us so as to get the all possible decision tree orientations. But now, sorry. Now, friends, one more important point. Suppose if I want to perform some kind of the unsupervised learning, because from long back we were discussing, some sort of supervised only. We are addicted to that supervised learning and all those kind of the thing. That is okay. Now, if I am asking you guys, can you help me to understand what exactly the unsupervised kind of the aspect? Okay, so how do you refer those points?
In unsupervised learning, we do not get any outcome like what we get in this either regression or classification. Yeah, supervised. We only see the trends based on that.
Correct.
The customers like retail domain, they can decide on how they can change their.
Yeah, suppose I'm having some data. The data may be having some kind of customer information. So some serial number, customer name, some kind of the income range, and here whatever he purchased, that particular stage or something like we have seen. We are having this information only. Now you observe here, based on the income. Okay, so maybe we are having some his income and as well as the information about the customer and how much he has spent on the corresponding shopping or purchase. Okay, this is the data, friends, actually. So in that particular case, if you keenly observe, there is no label actually. Label in the earlier examples of the supervised learning, we'll be having some label. Always we are going to find out that particular label. So whether he purchased or not, whether that particular email is spam or ham. Okay, so all these kind of the things. Whereas in case of the unsupervised learning, there is no such cases, friends. Especially, we are going to discuss the clustering concept in the today's session. This particular clustering really helps us to observe the patterns of the data. Okay, patterns of the data. So here pattern, to understand the data or to get the insights of the data. Basically, it is not providing any yes or no kind of thing or values. You can easily observe the insights of the data, such as, in the earlier, whatever the data I'm having, this particular data provides the customer information. And there are some, suppose if I am taking the appropriate information like this, this is the salary range in the x-axis. And of course, I'm having some how much purchases he has done. Okay, maybe the level of purchase or how much he has spent on some kind of the purchases. Okay, so now we are having some set of people here. So just we are having some set of people here, and in the same range we are having some other set of the people here. Whereas the high salary range, we're having somewhere some set of members here, and some other members are also there like this. Now you see what it is explaining to us is, so just is it is a kind of differentiation. There are certain groups actually, like however it is starting from low to high, your spend is also, how much you have spent is also starting from low to high. Now if you see the groups, actually these things can be known as a cluster, friends. Actually, what do you mean by cluster? In general, group of similar items. Cluster is anything but group of similar items. So whatever the items we're having now, what is the interpretation, friends? Here, can someone help me? This is the A cluster, this is star cluster, this is C cluster, this is B cluster. So 4 clusters are there, and of course you can generate how many number of clusters, and we'll see how to decide number of clusters and all. There is one concept actually I will explain while dealing with the code. Now what is the observation from this, friends? What it is trying to give?
There are 4 groups.
4 groups basically.
One with I spent but low salary.
Coming to the star,
Yeah,
these
low
guys are having
salary,
the low salary, and they're spending also low.
Low.
Okay. Second one, A, their salary is low,
but
they're spending high, like me. Okay, it's like all of us. Okay, so now what about B?
I spent high salary but low spent.
Now C, friends, actually. High salary, high spent. Now just observe this point, friends. To a company, which group is targeted then? Targeted persons. The company got this particular data, and as a part of this unsupervised learning, as a part of that particular clustering, they got these 4 categories of the clusters. A cluster, as already mentioned, which is having group of similar items, that is nothing but a cluster. Now if you see these 4 clusters, so which one do you feel the company has to concentrate more?
High salary and low spent.
This thing actually, because ethical values like Tata and as well as all those members. Okay, but of course we can give some promotional offers to these guys. Next highest, like they are getting higher salary and they are spending more, but you can give some promotional offers or some kind of the things you can target. But but our majority target would be like high salary. What is that, Venkat? You want to say something?
If it is like banking, who looks at the data, they rely on that low salary and low spend. So they will give some offers like EMI options and all. They make people to spend with loans. And
actually, see, I'll tell you one thing. How many? Suppose if you are in India, Venkat, per day at least 2 or 3 calls you will be getting from HDFC or ICICI. Okay, we'll give the credit card and we'll give the some kind of the loan or balance transfer like that. Okay, so because they can easily convince these guys.
correct.
Because always, the person who is having the less amount in the hand and he want to spend more at the end of the day, he usually tempt so as to get some more loan or something like that. But already these guys, they are having high salary, and because
Correct.
they are spending in a I can say in a structured way, in a planned way. Okay, maybe he's having more savings or maybe shares or whatever, because we cannot figure out also. Okay, so in this particular case there are different options, but in the standpoint of As you mentioned, banking, they generally focus on the first category only, because the more fish can be caught in this particular region only. Because even if you are referencing this particular thing, these guys definitely, these guys, they cannot handle. Okay, because they're all having their own potentiality of giving answers. But these guys, you know, they can easily manage. Like, okay, if you are having EMI, we'll reduce the interest rate. Okay, and we'll increase the tenure, like that, you know, some kind of promotions or some kind of things they will be offering to these guys. Okay, okay, like, you know, so in the outcome of this particular clustering is it is providing some similarities, friends. It is giving some patterns, and it is giving some insights of the data. It is not directly giving any value. It is not saying yes or no kind of thing, but it is giving some understanding of the data. Okay, that's what I want to say. Now, one more point, here, if you refer, just think through, friends. Here, before starting of this particular clustering, do we need training or testing, or what exactly your thought process, and any metrics were there? Okay, so these two are the general questions you may get while facing the questions in clustering or unsupervised learning. And one more important thing, okay, along with the cluster, can you give another example of unsupervised learning? One is clustering, that is okay. Second thing,
We have MBA, market basket
very
analysis.
good. Okay, after naive bias, your favorite is MBA. What is this, Venkat? Or Lakshmi
We
is there in the
discussed
call?
we discussed about this data and example of a retail retail company, how they will look at the
Yeah,
sales of other
correct.
competitors.
Suppose one product is there, and whether after buying this particular product, definitely who bought the other product also. Okay, suppose one textbook is there, along with this book, which are all the other books the guys has purchased. So that means there are certain relationships, or there are certain support or confidence or lift. Actually, these three are the measures, friends, especially in case of the population of the association rules. And I'm going to introduce one more aspects called a priori. Okay, this particular a priori is nothing but based on the item set, based on the transactions, how these association rules are going to generate. Probably in the next session, I'm going to introduce this particular association rules and all. And next thing, friends, apart from that, which are all the other aspects we're having, most importantly, anything coming into your mind? Dimensionality reduction, which I can say as a principal component analysis. Okay, this is also we are going to I'm going to introduce these things, and thereafter, friends, for you, just let me introduce some other aspects in the coming sessions. Model selection criteria. How do we select the models, friends? Basically, on what basis we have to select the model? This is first thing, and of course, this is the major thing, because I have given this dimensional reduction. And second thing, friends, actually, I want to give you, if you remember, variable importance plot. This is another thing I want to give. Okay, above and beyond the things. Okay, so can someone help me? What exactly the criteria of the model selection? Because we know pretty model selection is nothing but while using that sklearn. So just we are having the concept of uh, just we are having that data pre-processing, we are having model selection, we are having metrics, we are having, and algorithm imports. All these are from the background of the scikit-learn. But apart from that, if someone asks you like which are all the, just I'm giving hint, friends, we are having multiple parameters, and we want to get the suggestions from the machine itself or from sklearn. Anything comes into your mind? Already we have discussed this point actually. Again, I'm giving hint in SVM also we have seen this. Grid search CV. This is one important technique. Second one, friends, anything coming into your mind? So as to balance all the data, so as to cover all the classes of the data. No chance of internet lost. This is not Wi-Fi. This is a Ethernet actually. There is no question of disconnecting or something. Hope definitely my network is fine.
Yeah.
Yeah. K-fold cross validation, guys. Okay, na? K-fold cross validation. This is the most important thing.
See, we work only on the data, no? Like grid search CV, it optimizes. If we have like, it's like when we select the model.
Model selection criteria within that model,
Okay.
which are all the parameters we can take. Because generally, you may be in trap of, okay, model selection means I have to select the classification algorithm or I have to. For that, you need not worry anything, na? Because
see,
see,
I was thinking that, yeah.
If you are generating the value, definitely it should be the regression. If it is yes or no kind of thing, definitely it is a classification. That is perfectly all right. But the model selection criteria is involving k-fold cross validation, the better model, I can say. But the question they are asking is in this context, friends, just be cautious. Okay, just be cautious, because you may be think through like model selection in the sense based on the yes or no, I can elect the classification. Based on the value, I can elect the regression. That is not actually the case, because based on this particular grid search, which is giving us the suitable parameter list to just to after giving this particular suitable parameter list, you can have the implementation in a better way. And k-fold cross validation, can someone help me to get that, what exactly it does? K-fold cross validation.
It removes the overfitting.
Through what is the procedure? Yeah, that is you have
bias variance trade-off in that we have seen to
bias variance trade-off. And one more thing, it is going to distribute the data in a proper way. Okay, suppose I'm having some 1 lakh records and I'm having some 20 classes of the data, maybe all the states of India, assume that. So I need to get all the states information in one sample. Okay, all the distribution of the states must be there in each sample. Okay, that is how you can refer the k-fold cross validation. Now, can someone help me, friends? What is the importance of the variable plot? Because this is also reduces your work actually. And if possible, I can one more thing actually. If you remember, recursive feature elimination. This thing also I have introduced you guys, because these are all above and beyond our curriculum, because the curriculum and all, maybe you are having variables, constants. We have never discussed about those things, friends. Don't worry about that. Okay, no one is asking you just to declare a variable or define a constant kind of thing. But my worry is okay, so these advancements, whatever we are seeing, okay. So model selection criteria, variable importance flat, and recursive feature elimination. Okay, so these things, okay, I'm going to cover. Now, if you are referencing the random forest to notify you, just to quickly give me the aspect of how we are going to, what is the template, friends? We are following. Just you can refer the templates actually. What is the template in the coding? So far we have seen. First one is
first import all the libraries.
Importing the libraries, and thereafter importing the data set.
Data with the pandas.
Before training and test set, what could be the other criteria we are having?
We'll be doing the encoding missing value imputation.
That is what you call the data pre-processing. And once the data pre-processing is over, then next what we need to do?
Training and
One more question. Recently, we asked whether feature scaling should be done before the training test set or after splitting of the train test split.
No, we do it after test.
Train test split. Okay. Reason
Because
behind
for
this?
test we do not. For test we do
Exactly.
not require the standardization.
Scaling and all. Okay. Very good. Okay. And there are one more question you may face. What is the difference between standardization and normalization?
Normalization, for normalization, we should have the normal data should be in the normal normal distribution, and that is affected by min max.
Exactly.
Max, and for standardization, it can be applied for all, and
mean and
it is
standard
like free
deviation.
from outliers.
Exactly.
When there are outliers, we can use that.
Exactly. Okay. So that observe friend, that is the standpoint. Actually, we need not know. You need not know about the formulas and all, but you should be able to specify in standardization. If you are not aware of that data distribution in the normal or any kind of the data, I can go with the standardization. But if I am pretty know that my data is in the normal distribution, then I can apply the normalization. Okay. Normalization works based on the min max, and our standardization works on based on the mean and as well as the standard deviation. That much is enough. And in case of the data pre-processing, we are having the missing value imputing, and as well as second thing, friends. What is the second important thing? Encoding techniques. Okay, which are all the encoding techniques we are having? Which are all the encoding techniques we are having?
Not encoding, dummy encoding, label encoding.
Okay. What is the difference between one hot and label?
Label, we use it for the output.
That means only if I am having some kind of
yes or no,
yes or no or 1 or 0, in those cases directly I can apply the label. Whereas if I am talking about the one hot encoding, maybe country I'm having some 3 or 4 countries are there, I want to convert into the zeros and ones. In that particular case, I can go with the one hot encoding. Okay, just to recollect all those things, friends. Okay, because we have seen those things. Now, as usual, just we are having the import of the libraries, friends, especially which are all the constructs available in the NumPy. Suppose if someone asks you, can you talk something on NumPy, which are all the points we can leverage?
It uses arrays. We
Arrays, yeah, objects, the basic
and we can
object.
do some statistical calculation.
Statistical implementations like mean, max, min, all these kind of things. And numerical Python.
Yeah, it is a base on which we have pandas.
Of course, for all the remaining libraries, maybe that is a Cburn or Matplotlib or even sklearn. The base point for all these mentioned libraries is NumPy. Okay. Now pandas, what is the specialty of the pandas? What is the benefit, friends? What is the advantage of the pandas? Pandas is providing us the
we can
series.
do more series where we can whatever we cannot do with the NumPy, like the adding or some on the series, we can do it using pandas.
Exactly. Yeah, if you see the pandas, friends, NumPy is not that much flexible in the adding of the labels or dropping the columns or adding some more rows or something like that. Whereas and moreover, if you see the group by options, or if I want to apply some mean or something, our data frame is so handy. Okay, for that particular purpose, we are making use of the pandas. And what for we are using the matplotlib, guys? For the visualization. Okay, if you see our visualization lectures, we have seen there we have seen some kind of the histograms, box plot, or plotting the appropriate values, scatter plots. Apart from that, we are having some Cburn, okay, heat maps, all those kind of things we have seen. Okay, so now the data set, however, what we are doing is as a general practice from naive Bayes and as well as the decision trees, we are using the common input data, and we are trying to observe which algorithm is giving the best. So far, which has given the best outcome, friends? Out of naive Bayes, we have applied support vector machine, we have applied on top of this, and these things we have seen. Okay, we got some kind of the accuracy out of those kind of the algorithms. Now, can someone explain me what is this ILOC and what exactly these two statement does?
ILOC is
Default, which is the indexed based location. And the first thing is, as we are mentioning colon, all the rows. Second thing is up to -1, friend. Just to remember one simple point. If colon is there along with the number, excluding that. If only colon is there, entire things. Okay, all the rows. And here one simple point is X is also known as independent variable. Okay, independent variable or else the feature vector. So those particular features, except that particular label, we are having the features. Now, if you see the Y, so all the rows I want, and I want to put only -1. What is the use of these values, friends? Though if I'm not giving values also, no problem, but by default it is written the data frame. Okay, so this particular allocation and all written the data frame. But my interest here is I want to make use of this particular X as the arrays. Okay, so just observe here, if I'm making use of, like if I'm adding one more statement here. No, not here. 1 minute, guys. As you expected, if I'm giving some type of X, see it is giving array. Now you can easily observe our sklearn is also expecting the arrays only, because that scikit-learn library is very flexible with the arrays notation. So that is the reason you are making use of these particular values. Okay, so just to be mindful. Now, after getting this particular data into X and Y, what we are doing, just we are performing the train test split. Four outcomes we're having: X train, X test, Y train, and as well as the Y test. Now, if you are making use of this particular train test split, friends, we need to give the feature vector and as well as the label. Okay, Y. What is this for? Test size. Oh, friends, what? Which is nothing but the just we are taking the test 25% of the data, we are splitting and we are separating that particular 25% for the testing purpose. That means so as to verify the predictions and compare the original data with the predicted values, all those things. Okay, random state we know for the sake of comparing multiple algorithms, same in the same benchmarking kind of thing. And X train values I have printed, and Y train as usual X test and Y test. Okay, there is a normal printing. And now why we need to perform scaling, friends? Here, can someone help me? What is the reason behind? Just to go through the data, we are having some kind of the data here. Let me print the data set. I'm having the age, estimated salary, purchased, all these kind of things. Any point is striking to your mind? Why we
have age and salary, so that will the algorithm will consider the salary and it takes as high priority and works on that.
Exactly. So one thing, friends, the problem with some of the machine learning algorithms is they consider higher values as high priority values. So to avoid that particular confusion, and if I'm saying you, for some of the algorithms you can use the feature scaling, and for some of the algorithms you need not. That is not a standardization. Okay, that is not a generic procedure. So what we are doing, friends, if such kind of age or salary or experience or something like that, if any information is there, then in that particular case it is preferable to have the feature scaling, so that you can have the same kind of the scaling without misinterpretation of the misconception of the algorithms. Okay, so especially this cause disturbance whenever you are having the distance computing and all. What is the algorithm we are using for distance computing, friends? Which algorithm we are using the distance computing? KNN. Okay, so KNN basically helps us to observe the best classifier, but there we are using some kind of distance calculations. Okay, whereas the probability based algorithms, if I am asking you, which are all the probability based algorithms?
We use logistic regression and naive bias.
Logistic, naive bias, and any other? Yeah, what is the specialty of the support vector machine?
We calculate the margin.
Margin and kernel. Kernel trick is there. Na? So non-linear data items also can be worked with SVM. And what is the specialty of the decision tree?
We can work both on classification and also categorical, and it's faster. It's faster.
But before that, guys, just you observe these two are valid points. But before that, we have to see some statistical measure wise, we are having information gain or entropy, and as well as the Gini index. Because in other algorithms, just like that, we are having some kind of the KNN and SVM directly, and the algorithm itself is making use of the default parameters. Whereas if I'm talking about the decision tree, there are certain measures, friends, actually, certain computings actually, that is Gini index, and as well as the information gain or entropy. Okay, these kind of the measures are very much helpful, which are giving additional strength to the algorithms, friend. That is the major important point we have to recognize. Now, there are distinctions actually here in the feature scaling. We are seeing many at times. If you refer the difference between fit transform and transform, now you should able to tell why this particular extrain is needing the fit transform and why test is not, we have not used the fit. What is the difference, friends?
No, for test is only used to calculate the Y predict.
That's it. We are not implementing any model actually. We are hardly predicting the things. We are making use of that X test, whatever the values we are having, just we are making use of for the predictions only, not for the implementation. So that's what we are making use of the fit and transform. And once these things are over, so just all the age and as well as these things come into the same kind of the scale, then what is the next important thing, friends? We need to have the implementation of the model. Okay, now what is the difference between decision tree implementation and this random forest, friend? Let me open that one also. Decision tree we have seen, so that you can compare the statement wise also you can observe. Now if you refer almost the same kind of the implementation, and thereafter we have seen, yeah, this one, friends, actually this is a tree model. Actually, if you see, this is nothing but a tree model. From sklearn we are having the tree model, and from that we are making use of the decision tree. Why we are mentioning this as a classifier also? Why we are giving the classifier additionally? The reason is decision tree regressor is also there. That's what the reason we are making use of the decision tree classifier. Okay, now if you refer this point of getting the decision tree model, we are importing that thing with the help of the tree based model, sklearn.tree. But if I'm talking about the random forest, this is the ensemble. What do you mean by ensemble? Just now we have seen ensemble learning. So friends, you are what do you mean by ensemble, friends? Nilima or Lakshmi? Ensembling means integration. Okay, adding of multiple things to form a finalization. So here, if you refer the random forest, as in the beginning of the session, we have seen random forest is a combination of the decision trees. Many decision trees I am having. I want to integrate all those particular decision tree to form a single model, that is a random forest. I can say like this, friend. Suppose I'm having some 3 or 4 friends with me, and I need to take some decision to start new course or to publish new article, because some other researcher also there with me, like Venkat, Suresh, Lakshmi, like that. So in that particular case, definitely with all these 4 guys, we can publish some meaningful article. Like Lakshmi is good in coding, Venkat is good in analysis, Suresh is good in database kind of thing, and I'm good at some kind of machine learning or data science stuff, so that we can come together and we can integrate, that is ensemble. Okay, just to so as to generate a product, and we can submit these things to our Nilima or Akash, whoever. Okay, so that they can analyze the data. Okay, so but before analyzing, we have to integrate that. So that is what, you know, so just you can be observe. It's not the tree model, friends. Random forest classifier is not a tree model, but we are getting that thing with the ensemble thing. Remaining things are as usual. Okay, so just you can see this random forest classifier. As usual, we are having some reference and fitting the model on top of X train and Y train. Now, let us spend some time with these things. How can you observe these 2 points, friends? Any point is coming to your mind? What is that criteria? Somewhere we have seen
we are selecting the entropy as a
entropy.
criteria for the
Rather
scale.
than Gini, rather than Gini, I'm selecting the entropy. What do you mean by n estimators? Something should come into your mind immediately.
Number of
Trees.
like
That's
trees.
it. Number of trees. Okay, maybe I'm randomly giving 10, or else I want to give 15. Okay, based on those kind of things, okay, you can easily mention what exactly the number of trees I'm considering, and after that ensembling of these kind of thing with the random forest classifier. Okay, so it is simply saying you have used the criteria entropy and n estimators as 10, you get random state. Okay, that is not having any impact on this. We are using this particular statement, friends, from naive bias and SVM kind of thing. What is this for? We are verifying a particular age corresponding salary, whether that guy has purchased or not. He has not purchased. Okay, on the single data rather than projecting on the multiple data. Now what we are doing, friends, here, Y prediction, we are having the reference dot predict of X test. And here a simple notation, what we have done is in the earlier sessions also, we are bringing together our prediction values and as well as the test values. Okay, what is the use of this reshape, friends? In the earlier, I have shared one recording. There also I have discussed about shape and reshape. Shape is nothing but whatever the values I'm having. Here, you know, there is a distinction actually. So Y test is whatever the values I'm having and Y prediction. So I am getting these particular things into the common shape, because I want to compare and I want to maintain those two outputs into a common record fashion. So generally there are two options, friends. One is concatenate, another is VStack is there actually. Nowadays, this is also they're asking, friends. Let me give some impact on that. In the earlier examples also, if you followed that NumPy lecture or Pandas lecture, you can have that.
Yeah, VStack is there.
Concatenate versus VStack. Now what we're doing is in the scenario 1. So we are having the Y prediction and we are having the Y test. And we want to concatenate these two because these predictions are the model based. These tests are our actual data. Okay, so what we are doing, I want to publish these things as a common entry. But in the second scenario, the same example I am giving you guys, if you could give the answer, just to give the answer, I'm having the age, weight of the person and height of the person. There are certain selections, assume that. Okay, maybe certain kind of the selections we're having. And now individually we are having these three arrays. Okay, now I want to get, like, you know, some 1 lakh records I'm having. Okay, 1 lakh records I'm having, and all these particular 1 lakh records, they're having this age, weight.
We are not seeing the screen.
Oh
I
really?
don't know
Oh,
what
sorry
are
guys,
you.
sorry guys. Yeah, sorry. Yeah, this is the problem with Zoom actually. Okay, I thought of in Teams, because Teams, we just after sharing everything will be okay. Now just to have a look on the first scenario, friends, again I'm repeating, concatenation versus the VStack. I'm having the Y prediction and as well as the Y test. In the Y prediction we are having the model, and in the Y test we are having the actual values. So what we are doing, simply we are concatenating, friends. their correspondence is required or just concatenation is required here? There is no correspondence because wherever 0 I am getting, I need not get 0. Whatever the actual value I am having, that value is enough. Na? Though it is 1 also perfectly all right. Only real values we are going to concatenate. But here, observe, we are having some kind of columns, age, weight, and height. Now the thing is, suppose if I am picking a person, correspondingly I should get the weight, and correspondingly I should get the weight. Okay, height. So in that case, we are having the V stack actually. Okay, which is nothing but vertical arrangement of arrays with the corresponding data. Okay, with corresponding data. That means if you are having age, correspondingly the same person's weight I have to pick up and same person's weight. It's not random, friends. Okay, so after restacking these particular age, weight, and height, I can simply apply mean value, median, minimum, and maximum. I strongly recommend you guys. Yesterday, I have shared you NumPy and Pandas lectures. Okay, so just you can go through and have a look on those kind of the considerations. Okay, now apart from these things, if I am talking about the other aspects, okay, so once I got these particular results and comparison, next is as usual, friend, there is no differentiation between a random forest and decision tree kind of the measures. In both the cases, I can make use of the confusion matrix or accuracy score. If you see the this particular accuracy, I got 91% of the accuracy along with what is this for, friends? How can I distinguish these four? Use the chat window or unmute yourself. You can say which are all the 4 parameters, friends. In that is a matrix format. Now I have highlighted something.
True positive, true negative.
True positive, true negative,
false positive, and
false negative. Yeah, yeah.
The
Okay.
diagonal ones are true positive and
true positive. Yeah, yeah. True based entries. And remaining 5 and 4, the values must be very low. Then only I can say my model is doing well. And these 63 and 28, the diagonal, whatever we are talking, those things must be high. Now, can someone help me, friends? What is the difference between earlier statement and this one? Again, we are fitting the model actually. In the earlier case, criteria, what is the criteria we have used? Entropy. Now, what is the criteria I am using? Gini. Observe, friends. See, in the earlier example, I have used the entropy, same statement. Okay, from sklearn.ensemble, import random forest classifier, just the reference value and as well as the corresponding algorithm and giving the parameters, number of decision trees and what is the criteria. But whereas if I am talking about the other thing, we are having other thing also na Gini index. So this time I am taking some 20 trees. I have changed my criteria, and though I am changing these things, I got the same kind of the accuracy. Okay, maybe that is what, friends. If I am simply changing the criteria, I may not get the differentiation also. Okay, that we have to work out. Maybe if I am changing the number of trees, so can I get some kind of the better accuracy, or can I reduce? And even you see, this is one kind of the value we got in Gini kind of thing. Let me paste this thing here so that we can easily differentiate, because accuracy wise both are same. Okay, this is one thing we got. Another thing is this is related to our Gini actually. And one more thing, let me pick up that particular confusion matrix also. 1 minute, guys. So where is that entropy? And after getting this particular entropy, we got yes, copy. Sometimes this OneNote is causing trouble. Can someone confirm me, friends, which one you are seeing, whether OneNote or
now it's good.
okay, now you are seeing na OneNote only, na? Okay. Hope you are seeing OneNote, right? Okay. Now see, friends, there is no differentiation both in entropy and as well as the Gini, but this is a rare kind of thing. Exactly. You know, the accuracy wise, we got 91%. Okay, here also we got some 91%. Okay, that means the model is not biased exactly, it is performing well with the corresponding estimators and all the, maybe if you are using entropy also, Gini also, it is doing well. Okay, so based on this particular convention, you can say that the data itself is settled, and we could able to observe that particular data in a train test split kind of the things. Okay, but we have not yet discussed that particular model selection criteria, and then variable importance plot. Those are all really helpful, friends. In case of the decision tree and random forest, again we'll revisit those aspects, because in the lines of variable importance plot and as well as the RFE is there, recursively freeing that particular feature. Okay, recursively eliminating that particular feature. Those things are really helps you guys. Okay, because more or less these algorithms are same in any kind of implementation, but only your strength is you have to prove your strength in the usage of that grid set CV, k-fold cross validation, your stat, your effort of that particular stat, explanation in case of the metrics, and the dimensional reduction techniques what we are using, and then all these kind of things are definitely you need to focus. Because if they are asking the questions in any kind of the algorithm, you can easily give the answer. But because they can twist you in terms of statistical orientation, and sometimes with the on the grounds of the metrics. And other important thing is the measures, friends. Actually, measures I am talking about, in decision tree we are having certain measures like entropy, information gain, Gini kind of thing. In support vector machine we are having certain specialty related to that kernel trick kind of thing. Okay, so just you can focus on those kind of the conventions. Now most importantly, one more point in the discussion of this thing is the clustering, friends. Actually, so let me introduce this particular clustering with you. As usual, let me walk through what exactly this particular clustering is, and then let us see what is the difference between normal supervised learning kind of the algorithms and as well as the unsupervised kind of the aspects. Okay, so just you can have a look on this, friends, and just you can observe, you can reply me in such a way that where we are getting the differentiation. Okay, any difference is there here importing the libraries? No. Okay, numpy, matplotlib and as well as the pandas. Okay, what do you mean by this thing, friends? Importing the data set, as mentioned earlier, na same example I have taken in the session also. We have recorded the customers who visited our malls in the earlier. So we have taken all that particular data item. And one more thing, friends, here, what is the use of ILOC and this thing? Okay, but before that I have to print this particular data set. What I'm doing here is, guys, just let me use this particular yeah, data set. Okay, let me import this thing. So just we are importing, and we are using this particular mall customers, and let us see first time what exactly the data is. Now observe here, friends, customer ID, gender, age, annual income, and the spending score from 1 to 100. 100 is highest spend score and 1 is the lowest spend score. I can see here just this guy. Okay, with customer ID 2, he is male, age of 21, annual income some 15k dollars, and as well as he has spent 81. Similarly here I can see in this data set, friends, in this example, female, age 20, 16k dollars, and spent is very low. Okay, so this is how you can refer on what basis. Okay, so just this is the data we are having. Okay, let us not move into the discussion. Okay, because we need to discuss our results only, not about the data set. Data set we cannot do anything now. Only we need to understand the data. That's it. We need not analyze that. We have to understand that. Okay, so from this particular data set, we are having the customer ID, gender, age, annual income, and as well as the spending score. Can someone help me from this? Can I pick up any label, friends, by chance? Any label can I?
No, we are not having any outcome in
Because
this.
here we are not getting any outcome, or this is hardly a spending. That score also we don't know how they have generated. This is also not revealed. Na? We are not knowing about how they have computed this particular spending score also. This is one thing. And the label generally yes or no kind of thing, or some kind of the number. But in either case, the spending score is something like which is not direct value actually. Okay, but here after getting the spending score also we cannot do anything, because if it is the purchased data, whether that guy has purchased or not, whether that mail is spam or ham, we can do some analysis. But here though I am getting the spending score also for that particular customer, I cannot do on the individual basis. So let us move on. Here what we have done, friends, what is this allocation? Just observe here, allocation, indexed location, okay, which is fetching all the rows. And what do you mean by this 3 4 friends? I need okay, this is customer ID 0, gender is 1, age is 2, annual income 3, spending score 4. Is there any impact of customer ID, friends? Customer ID, gender or age? Maybe, but what we are considering? Annual income and as well as the spending score. Though if you are talking about the case study, this particular case study is expecting the salary range and as well as the spending score. That is our requirement. In that particular case, we are not interested on the age or gender or customer ID information, so that we are fetching only 3 4. Okay, that too, these particular X is containing the array of all these annual incomes and as well as the spending scores. Now, what is the difference you observed between the earlier example, earlier case studies and this one? Quick friends. What is the difference we have observed? There is
Not
no,
taking all the values.
there is no Y. Okay, so this is one thing. And all the values generally we won't use. No? Sometimes in the earlier case studies, maybe according to the requirement, we could have taken all the values as features and last one as the I can say label. Okay, but sometimes you can restrict. That's what I'm saying. In the next coming sessions, maybe in the dimensional reduction and all, you can have a chance of picking up the independent variables also. Okay, right. Now this X array, whatever. Now you see, friends, here one more point. This is little bit distinct with our normal supervised learning. Now let us have a discussion, friends. Actually, suppose while dealing with some kind of the clustering, here what we are doing is scikit-learn dot cluster the group of that particular unsupervised learning, and we are importing the k-means. We are having k-means, hierarchical, like that we are having. Out of that we are using the k-means. Now what we are doing here is, friends, can someone help me what is this brackets refers? From Python data structures, I am giving the hint. Long back we have seen whether it is list or tuple or set. Friends, you are exactly in the reverse order. List. Okay, that if that kind of brackets are there, just I am strongly recommend you guys just to revisit at least the class shell. Okay, whatever I am sharing with you, one note, just to go and open that Python, the corresponding one note, and these are all the bare minimum expectations, guys. What is a list, tuple, or all these kind of the things. Okay, now what we're doing here is the for loop is the repetition. Okay, just here I'm mentioning number of clusters, and I'm making use of my algorithm as k-means plus plus. and then we are directly fitting. Don't worry friends, I will explain in a clear cut way. Just this is a walkthrough now, just be with me. And every time whatever the value I got, okay, so just I have appended with the list. Now what we are doing is just we are printing this access, okay, elbow method as a title, and my x value is x-axis is number of clusters, and y is within the cluster sum of squares, because this is a measure where you can refer the observation of the distance. Internally, if I am talking about the cluster, is nothing but the group of similar items. Na? So similar item on what basis? Similar item on what basis means the same kind of the characteristics must be there in the same cluster. Suppose if I am taking cluster 1, the elements if I am talking about, those clusters must have the same kind of the characteristics. If you are comparing between cluster 1 and clusters 2, okay, there is a distinction between first cluster and second cluster. Dissimilarities are more, okay, between the clusters within the cluster. So now if you are referencing friends, what you are observing from this graph, you tell me. Leave about the clustering and all the technical things. Just if you observe this particular graph, is there any important thing you can recognize from this point? Just to think through friends. Is there any
as the number of clusters increase, the WCSS decreases. You know?
That is one thing. Any other?
Like till like 3, it's like steep, and then it was kind of
yeah, 3 it got some elbow shape. Elbow is there, na? Elbow, and even after this 5 continuous decreasing of the clusters. Hope you got the point friends. Here at this moment it is traversing, okay, and a little bit, okay, some just it is going low, and from 5th onwards, that is number of cluster 5, then obviously it is going down actually. That means
the proportionality is not there in that middle.
Correct? Exactly that means after 5, if you are giving 6, 7, 8, 9, 10, no matter. That means there is no effect on the appropriate outcome. So what is this elbow gives friends? Now you can got the point. This particular elbow specifies that what is my optimum number of the clusters, because I cannot randomly give that particular cluster. Na? I should work out something, and based on that particular point I have to observe. Okay, so from that particular point, if I am giving the number of clusters more also, there is no difference in the results. The same thing if you observe 5, at this moment I can able to verify the proper results, and here the dropping is there. This is what you call the elbow method. From this particular elbow, the remaining points are coming down friends actually. Okay, so this is how you can refer the usage of the elbow. Now just observe here, very simple. The k-means, this is a reference. I am sending arguments to this particular k-means algorithm. Now how do I get this number of clusters friend? From the elbow method 5, and I am making use of the k-means random state that remains same, and fit and predict friends. One more thing, just what we are doing is here I am getting the outcome fit and as well as the predict. Now let us understand this particular outcome. What do you observe from this outcome friends? Because there is nothing to compare with the existing thing, but we got some insight. Just to observe, spend some time so that you can able to give the answer. What is that 3, 0, 1, 2, 4 refers? Think through friends.
We have the 4 groups.
Exactly right.
1,
you know,
2,
0, 1, 2, 3, 4, those are all the 5 groups we are having, and those particular 5 groups, first group is the first element is third group, second member belongs to 0th group, again third member belongs to third group, fourth one 0 group. Hope you got the point friends. Here it is giving us the segregation of the groups related to the members. Okay, now okay, just I am leaving this code part friends for you only, very simple, just to give a try, otherwise I will explain, no problem. Now you see the diagram. Okay, what is this diagram friends? In the class or in the session also we have seen We are having 5 clusters actually. Cluster 1 is red colored. Cluster 2 is some kind of the blue colored. Cluster 3 green here. Cluster 4. Okay, this one, and cluster 5. And the last one is the centroid. Okay, what is the use of that centroid, friends? Basically, what is the benefit of that centroid?
No, to measure the distance in case we
Exactly,
want to.
that is what, see, the cluster computing is completely based on the distance. To measure that particular distance, definitely I need to have the some measure. That measure is the centroid here. So based on that particular method, our clustering is going to compute. Okay, we are going to compute various kind of the aspects, and these particular computing helps us to refer, okay, how similar the values are, so that it is picking up and placing in one group. Okay, like that. Now observe here, friends, which group is more precise actually?
The center.
This one is more precise. That means I can easily say there is no outlier or nothing disturbance. And even this group is also good, friends. If you see low income, low spending, low income, high spending. Okay. And 40 to 60K annual income, they are also performing some, we can see the thing. But there is a scatter here actually. If you observe, between this particular 80 to 140K dollars, both the members were there, friends. I can say the members who are getting average to maximum salary, okay, they spread like this. They are spending very low. Whereas if you focus on these particular things, of course, average to maximum pay or maximum salary, they could able to spend more. Now out of this, which is our target audience, friends, as a company point of view? Cluster 5 or cluster, I mean cluster 4 or cluster 3 or cluster 5? What is the your thought process? Which one is our target? Because we got clusters now, and there we have seen some 5 different clusters, and all those particular clusters are giving some kind of the information. Now let me do one more thing. So rather than taking this 5, I need to run this particular thing again. So I have executed up to this, and thereafter the data set we have seen, and thereafter X value I need not. Okay, now you can run this particular thing so as to find out the elbow. And once that is over, just what I'm doing is here, just I'm making use of this cluster means and visualization of this cluster, and we could able to see the outcome. Now what I'm doing here, friend, just let me increase this particular thing or decrease to 3 clusters rather than giving 5. Now I'm limiting my clusters to 3. Now let me visualize this thing. And again, if I'm giving this particular outcome, only I could able to see 3 clusters. Whether 5 is good or 3 is better, friends. This is actually 3 clusters.
No, 5 is good.
5 is good. Why?
See, it is spread, you know, the one group, cluster 1 is spread from top to bottom. Like cannot.
there is no pattern actually. It is spread over actually. Spread is not a pattern. Pattern is different. Now, if I'm changing here itself, you can easily realize, friends. If I'm giving 4 also, let me see the impact of giving 4. 4 is bit okay, na? But still it is also causing some kind of okay.
I think the 5 looks better. 5 looks
Even, fine actually.
6 and 7 may not look good because
yeah,
of
exactly.
the
If you are saying this 5, now if you run that is the power of elbow, friends, actually. So we could able to see that particular importance of that elbow, and we could able to impact. Okay, now you see is a clear cut. Rather, if I am changing this to some 8 or something like that, let us give that. That also will see, so that we can able to observe the 8 clusters. What is the problem? Centroids were spread over, but there is no cluster at all, which is a nonsense, na? See here, 1, 2, 3, 4, 5, 6,
Only 5.
7, 8. But 5 only generate. Of course, we have seen this 5 only I have maintained to display. That is fine. Maybe even if I am not giving also, it is spreading somewhere. But really, it's not looking good, friends. Okay, so that means definitely elbow is having impact on the understanding of this particular clustering technique. Now you refer and compared with the less number of the clusters, and we have seen the more number of the clusters also. Perfectly, that centroid is fixed around these 5 kind of the clusters. Now you can easily realize that this particular elbow is really playing a vital role. Okay, so up to this particular point, this is the perfect observation of the elbow method. Okay, with the help of that particular method, I can able to generate the number of clusters, and that too in a proper way. Now what I'm doing here, friends, I will be sharing this particular document with you. I recommend you just to go through this code, because you are not responding in a way how we are responding to algorithms or metrics or whatever the aspects we have covered. But at this moment, okay, you need some kind of the understanding of this particular code also. Understanding only. You need not write the code entirely, whatever we are having. Just you need to explain the code, and you have to paste that particular code according to the requirement. That much is required, friends. And to do that also, you have to have some kind of the usage of the corresponding code. Okay, so that is what how you can refer the implementation. And some other aspects I'm having here, that is what hierarchical clustering. You know, the hierarchical clustering, what it says is it is basically giving the usage of, okay, the same clustering mechanism on the same data. Now what we are doing is rather than using the elbow kind of thing, this time we are taking the dendrogram. Okay, this is one another methodology, okay, based on this particular convention. Now you see, friends, here 1, 2, 3, 4, and 5. Clearly I can see 5 clusters. Rather than giving the number, it is directly giving the image, friends. Okay, you can easily see this. Now here also I am taking based on this diagram. Okay, based on this diagram, I can able to refer, oh, 1 cluster, 2, 3, 4, 5. Total 5 clusters, so that I am giving this. And affinity means somewhere we have seen this Euclidean, friends. Where we have seen this? Can someone help me? Euclidean distance, cosine distance, Euclidean distance in the KNN actually. So KNN is a method or algorithm where you can refer the usage of the distance calculation. Similarly, our clustering also, so as to perform some kind of the similarities, we are making use of this Euclidean. And now clusters are same number of clusters, and here also you can see the same kind of the thing. Okay, with respect to k-means or hierarchical, just there are certain differentiations. In the k-means, I am using the elbow method. Here I am using some dendrograms where I can apply. So this kind of the technique, so as to give the number of clusters. Otherwise, the remaining aspects are all same. Just importing, loading of the data, and usage of this thing, rather than taking the, yeah, one more point, friends, here. Just I want to highlight. In case of the clusters, okay, that means k-means, we are having the, if you observe, this particular k-means, I'm going back. Just if you see here, sklearn dot cluster import k-means. Okay, and one more package we are having, okay, just in the literature, that is a SciPy actually. Scientific Python, friends. Here temperature or pressure, all these kind of the physics or mathematical kind of the computing I can have in the SciPy. Okay, SciPy is nothing but a scientific Python, friends. So all scientific things. Now this hierarchy and all these things are available with the SciPy, not in the sklearn. Just be cautious. Okay, maybe if the member is very passionate about unsupervised learning, and if he want to grill you on the grounds of this particular clustering, then he can ask this. Okay, whether sklearn is containing hierarchy or not. You may say that, okay, every algorithm is we are importing from sklearn, though you can say maybe, okay, you can reply that sklearn, but the answer is not correct. Okay, definitely you need to observe the differentiation between the k means clustering and as well as the hierarchical. So that is the specialty. That's what actually I thought of sharing this one uh, with a specific understanding. Okay, so there is a distinction between sklearn and as well as the scipy. Sklearn can be used for data pre-processing, model selection, and as well as standardization, normalization, standard scaler. All these things we're having along with the algorithms also. The kind of algorithms also we have seen some classifiers, and thereafter we have seen some algorithms like the tree-based algorithms, ensemble learning, like that we're having. But whereas especially in all the algorithms, there is one common point, maybe that is the supervised or unsupervised. The common mechanism is the sklearn only. But whereas especially in hierarchical clustering, we are having the scipy, scientific Python. Okay, so this one, be cautious. This thing also I'm going to share with you. However, I'm going to explain once more. So, but my strong recommendation is just you can go and perform some kind of the research on these statements, which is very simple. Okay, just to observe, and however I'm going to explain in the next session. Okay, so that is what the today's session, friends, and let me close this session with the key takeaways. Okay, which are all the aspects we have discussed, guys, in the today's session. Just to reply back, key outcomes. Okay, we have started our discussion with the random forest.
Measures, like same measures as
same measures of classification, same as decision tree, but here we are having the estimators.
Yeah, we have seen bootstrapping.
Yeah, bootstrap, which is important. One more point we have seen in the random forest. What is that, friends? Along with the
ensemble collection of data.
This is one ensemble, which is clearly distinguishing between the random forest and as well as the decision tree. So, and second important thing is we have seen some unsupervised aspects, and within this particular unsupervised aspects, we're having the k means and then hierarchical. What exactly this k means, friends? It is based on the elbow method to find out the number of clusters. It is dendrograms. Okay, now both the things are dependent on the distance measures only. The distance common. And what is the difference between k means versus hierarchical clustering?
We k-means we take from sklearn, but
that is what.
Is that because of data we took it, or for all
hierarchical? No. All hierarchical should come from scipy only.
So unless the data, then it depends on the data. If it is scientific data, then only we'll use hierarchical.
No, actually, see, suppose if you are if you want to perform the statistical calculations or missing value imputation, or else your feature scaling, all these things comes under the category of the sklearn. SciPy or scientific Python used by the physicists and as well as the mathematicians. Basically, see, this is a temperature calculations, all the logarithms or exponentations, those things are there in the SciPy. At the development of this dendrograms and as well as the hierarchical clustering, okay, they have implemented those things in the SciPy. That is only the reason, friends. Don't think much. Okay, simply just to remember that all our algorithms may be supervised or unsupervised. Majority of our algorithms are from the sklearn import only. Hope you got the point, guys. Whereas except this particular dendrogram, because the dendrogram is something like which is a measure, okay, and along with that hierarchical clustering, we need to have that particular computing. So for that particular computation, we are having this usage of the SciPy. So this is how you can refer. And comparatively, friends, if you observe the here itself, we will conclude supervised versus unsupervised. Can someone help me at least one or two differentiation, friends?
Supervised, we have always an result whereas unsupervised doesn't give any label kind of thing.
It is giving the patterns. Okay.
And when we apply the algorithms, we take
No
X
why.
and Y, but here no Y.
Third thing, any measures are there, friends, in the supervised?
We only see
Measures
that,
we are having in the supervised actually. Measures are there, yes.
no, because there are no results. We
No
cannot
measures.
take we cannot do the test train split, and also no measures we can.
Exactly. Test train split also nothing is there now. Okay. Train test split is there. We are not required.
Yeah. Instead of measures, we work on the cluster
Diagrams only. Yeah. Here we are having the elbow method or dendrograms to identify number of clusters. Fifth one. Here, based on the algo, the corresponding measure. Okay, so that's all, guys, for the today's session. But just I'm sharing this particular thing along with the code. Spend some time, because not a big deal, friend. Just to spend and use your source of whatever the data we are having, so that you can easily grab the things. Okay, that's all. Anything else?
No.
But my suggestion would be ask the other members also to attend the sessions, because these sessions are very crucial. Remaining 5 or 6 sessions, whatever we are having, because we are going in a different direction. Now you could have realized that in that, at least in the unsupervised learning and as well as the clustering,
Yeah.
there is a diversion actually. If suddenly the other members are coming and if they are attending the sessions, definitely they feel some difficulty, friends. I can
No,
say
I
that.
told he'll be coming from tomorrow, Suresh.
Tomorrow, now? Okay, then no problem. Okay, that's all, guys. Thank you. Okay,
Thank you very
bye,
much.
bye, bye, bye.